Hello and welcome to my tutorial today on preventing deadlocks during an exception in three different languages. So today I'm going to be using C++, Python, and Java, and I'm going to be explaining how these three languages use three different approaches to preventing deadlocks when there's an exception thrown during threading. So first I just want to go over a quick background on threads and mutexes and locks. So threading is just a way for a program to run simultaneous tasks simultaneously, and this is primarily done for speed purposes. Because if you can run two things at the same time, it's faster than running them one after another. The problem with threading is that it can lead to an assortment of bugs. One of the primary ones being a race condition, and to prevent this, what you want to do is you want to implement and use something called a lock. The general term is called a lock, and mutex is a more specific term for that. I'll be using that interchangeably throughout this tutorial. So what a lock does is it prevents different threads from entering a critical section at the same time. So there's usually one mutex, and once that's locked, only one thread can enter that critical section until the mutex is released or unlocked. Then another thread can enter it and will require that lock. So this is just a quick little background on threads and mutexes. This tutorial is going to assume that you know what threads are and mutexes and locks are. So if you don't know what that is, I suggest you read a tutorial and watch another video before moving on with this tutorial. So I'm going to use this example in all three languages, and of course I'll adjust it based on the conventions of the language. But this do something dangerous method is what I'll be using here. So you'll see that I create a mutex on line 3, and the critical section of this function is basically the whole function. So anything between mutex lock on line 6 and mutex unlock on line 17 is the critical section. Now this looks fine. However, the key to this is that the foo method that is ran on line 10 can throw an exception. So you'll see that I have a try-catch statement that encompasses the foo statement. So what happens if foo throws an exception, the catch statement is going to be ran, and it will just throw that exception to be handled somewhere else. Now the problem with this is that when the exception is thrown on line 14, that means that the function is exited. That means that line 17 is actually never ever called, and the mutex is never unlocked. This means that any other thread that's trying to enter this do something dangerous function will never be able to, and it will just pause there indefinitely. And that is called deadlock, and that is what we're trying to prevent here. So first, let's just look at how C++ decided to handle this problem. So you'll see here that I create, again, a mutex on line 3. But the difference here is on line 6, instead of just simply locking it, I will create a lock guard variable. And what the lock guard does is it takes the mutex as a parameter, and when the lock guard is created, what it will do is it will automatically lock the mutex that it was given. Now, when the lock guard unlocks the mutex is when anytime you leave the scope that the lock guard was created. So the very simple case is like if foo runs without an exception on line 18, right when you're about to leave the scope of the function, the mutex will be unlocked there. But also, you'll see on line 14, when you enter the catch block, the mutex will also be unlocked there because technically the catch block is a different scope. So this handles exception or non-exceptions perfectly fine. So that's how C++ fixes this problem. So very quickly here, we're just going to look at the Python example. On line 3, we create a lock, and line 6, we acquire it. Line 13, we release it, which is the same as locking and unlocking. And you'll see also the same problem here. You try to do the foo statement. If it throws an exception, you raise the exception, and the function is exited. And line 13 never gets called. So how Python tries to fix this deadlocking issue is with something called a context manager. And what a context manager does is it's a built-in mechanism that tries to help you manage resources. So this is often used when you're trying to open and close a file, but you can also use it with a lock. So if you do use the with statement or a context manager with a lock, is when you enter this block, what will happen is it will automatically lock the mutex. And when you leave the block, it will automatically unlock the mutex, and it will unlock it whether you just normally exit the block or if you exit because of an exception. So it just automatically handles unlocking and locking for you. So now let's look quickly at the Java example. It looks very similar to the other two examples we looked at. On line 3, we create something called the entrant lock, which is just like a mutex. And you'll see on line 6, we lock. On line 17, we unlock, and we have that try catch statement in the middle there. So the way that Java handles this problem is it has something called the synchronized keyword. So you just use this synchronized keyword in the method signature, and it makes the entire method thread safe. That means that only one thread will be able to enter the method at a time, and it will handle all unlocking, no matter if it leaves the function normally or if it leaves it through an exception. So you see there, it's pretty simple here. There's no locking, no unlocking, just simply synchronized. And yeah, so just we have a recap here. C++ uses objects called either the lock guard or the unique lock. And Python uses the context manager, also known as the with statement. And Java has the synchronized keyword. So with these three methods, you can see the different languages has different ways of handling this problem. And I suggest you look deeper into the pros and cons of each, but this should just be a general overview and give you a quick and dirty understanding of how the languages have chosen to fix this problem. Thank you very much, and I hope you enjoyed this video.